Alright, welcome to this lecture number 15, and that is on again space geometry. In this lecture, we will first see what we have done so far. And in the last lecture, we are talking about an object, and we wanted to make this object by cutting smaller pieces out of a large sheet. The idea was, if we just fold those pieces or those sheets, we should be able to make this object. And then we saw that we will have to develop, say for example for A, I'll have to develop a surface like A dash, so that this A dash, when I fold, I will be able to generate the cylindrical form like A. Similarly for B, something like here B dash, and for C, C dash. Now all these things are covered under certain topics in this course. One is the auxiliary view. The meaning of the auxiliary view was, if I'm not able to see a certain surface, for example here this one, it is not parallel to any of the principal planes, still we want to know it. So the projection of this on the principal planes will be distorted in terms of size and shape. So what we need to do, we need to look perpendicular to that surface and create another plane, we call it auxiliary plane, and develop the orthographic view on that auxiliary plane, which we'll call the auxiliary view. So that way, because in an object there can be many lines, many surfaces, many planes which are not aligned, which are not parallel to the principal plane, but still through the use of auxiliary view we can determine their true shape and size. So this we will cover in space geometry. Next we will look into, as we see here, if two solids are intersecting, what is that surface of intersection? Okay, what is that form of intersection? We will need it. Finally, as we said, yes, how we cut a sheet, in what form we cut the sheet, so that on folding the sheet we can generate a certain shape, alright, or certain form. So some more things. One is on the view direction, as we had seen in the previous slide also. In order to visualize a surface which is not parallel to any of the principal planes, we need to look perpendicular to that, and this is called the viewing direction. Okay, the viewing direction. Alright, if you talk of a line, if this line is being projected, for example here this is profile plane, and the line is parallel to this. If I project it onto the profile, the view will be true length. So this view we call the normal view. However, for the same line, if you project it onto the frontal plane, the view will be a point. We'll call it a point view. Similarly for the plane, a plane being projected onto the horizontal, this plane is parallel to the horizontal, so the projection will be normal view, while for this plane the projection onto the profile or the projection onto the frontal will be S view. We'll make use of this learning and take it forward. First we'll like to talk about lines, some definitions of the line. We'll try to understand this, and these definitions are very common. What is a line of infinite length? The segment is between 2 points, shortest distance to connect two points is a line, and then we will know the direction. This is, we will see later on. If I know the projection of a line on two orthographic planes, I will be able to determine the slope of this line. Okay, so how to represent the slope, all these things we will see later on. Now some classification about the lines. Let's do one projection. Here in the projection, I'm drawing here the hinge lines. We know what is the meaning of the hinge line. Just think of this. You have to visualize again in my lectures later on. There is a glass box which is kept here. This is the front face of the glass box. So for you, it is the frontal plane. this is the profile plane, and this is the horizontal plane. So visualize this. Inside, an object is kept there. So this object will make its projection here, here, and here. Alright. So the frontal plane, horizontal plane, and the profile plane I'm showing over here is horizontal, frontal, and the profile. So this notation I will use mostly if there is a change of the angle of projection, third angle, first angle. I will talk about that later. So there is a line, and the characteristics of this line is this line is parallel to the frontal plane, as well as this line is parallel to the horizontal plane. So what will happen, this line will have a normal view, true length onto the frontal plane. It will have a true view or the normal view onto the horizontal plane, while this line will have a point view onto the profile plane. Let us see it. So these two views are normal. As I said, using the middle line and the projectors, we can form the view on the profile also. So on the profile, we'll get the point view as we have just seen. Something on the notations. Just look at the notations. For the line AB, I'm writing it as AF, BF for the frontal projection, AH, BH for the horizontal, and over here AP, BP for the profile. Okay, we'll use this notation everywhere. Now this kind of line we will call this line as horizontal frontal, because this line is parallel to the horizontal and frontal. So it is parallel to the frontal, parallel to the horizontal, while point view onto the profile. So that's the name of the line. Once we have understood this, we can have more such lines. There is horizontal profile. So a line which is horizontal and parallel to the profile also. So this line is parallel to the horizontal, parallel to the profile. So its projection onto the frontal plane will be a point view. So what we will do, we'll start with the true view. Where we form the true view? We form the true view onto the horizontal, we form the true view onto the profile. Okay, let us draw it. So hinge lines. So let the view on the horizontal, the true view, because the line is also parallel to the profile. So on profile also I will have the true view. Let us draw the true view onto the profile. So that's the true view on the profile. Now with the help of these two, we can generate the point view onto the front. So this line is called the horizontal profile. Similarly, if you go further, a line which is frontal profile. Think of that, frontal, the line is parallel to the frontal and profile. Okay, so how will this line be? This line will be something like this, because this line is parallel to the frontal and parallel to the profile, while onto the horizontal plane it will have a point view. Can you draw the projection of this line? Just try it and pause your video, look at your video again afterwards. Alright, you have done it. Just check it whether your answer is correct or not. So here we have the hinge lines, the horizontal, frontal and profile. The line has true view, normal view onto the frontal. So this is the normal view. Okay, similarly it has normal view also on the profile. Alright, now with the help of these, we will be creating the point view onto the horizontal. Now one thing here, just take note of one thing. I could have drawn, the projectors from the frontal are going like this. So I could have made AP, BP here also. I could have made it AP, BP here also, because I had a choice. Only in the frontal I took a line. So I took that in the frontal, and while I make it say 1, 2 and 3, what is the difference between these? Only in the frontal, wherever I'm going away from the frontal, so the projection on the frontal will not change as I'm going away from the frontal. Only the projection of the line is changing on the profile as well as on the horizontal. Okay, so I took this one because I could have taken any here. Okay, because on the front profile it is not fixed yet. So that's the point view. Now one more line we'll discuss, and this line is inclined to frontal and profile. Now what is the meaning of inclined to frontal and profile? Just visualize it. Frontal and profile, the line is like this, so it is making an angle with acute angle with the profile. Similarly, it is making an acute angle with the frontal. This line is parallel to the horizontal, so we will call this line as horizontal. Let us draw the projection of this line. So with the help of the hinge line, because the line is parallel to the horizontal, so we will draw first the horizontal view, which is the normal view. So this is the normal view. Now for this normal view, corresponding to this, now I am drawing the frontal, and now with the help of the frontal and the middle line the projections, I can draw the view on the profile. So what you will notice, the view on the frontal and the view on the profile are foreshortened. They are not true views, they are not true lengths. Okay, we go further from here. So this line is called the horizontal one. Another line, and the line we call as frontal line. The meaning of the frontal line means the line is parallel to the frontal plane while it is inclined to the horizontal and the profile. So this is how the line is. Projection on the frontal will be true, projection onto the profile and projection onto the horizontal will be foreshortened. Let's quickly draw the projections of this. So on frontal it is normal view, alright, the foreshortened view on the horizontal, and as well as the foreshortened view on the profile. We go further. Now I am giving you this exercise to you. You have to draw a line which is inclined to horizontal and frontal. Just visualize horizontal and frontal. So the frontal plane and the horizontal plane, the line is inclined like this. Okay, horizontal and frontal. So this line is parallel to profile, so we will call this line as profile. Can you draw the views of this? Once you do it, pause your video, again see the answer. Okay, I think your answer is there with you now. Let us do it quickly. So this line is inclined to horizontal and frontal. So the line is something like this. It is parallel to profile. So on the profile I will have the true view. So I will make a true view on the profile, normal, or this is true length. Then I will take it to the frontal. Again, I could have done it here, I could have done it here, it doesn't matter. Okay, but once it is fixed in the frontal, it is also then fixed in the horizontal view, and then the view on the horizontal. So both of these views on the frontal and the horizontal will be foreshortened. We take it further. There can be a line which is oblique. Oblique means it is not parallel to any of the planes. So this line will have foreshortened or distorted projection on the horizontal, frontal and the profile. Let us draw this line. Okay, with the help of the hinge line. Let the line is, I'm just drawing any line. Okay, its projection is appearing as this in the profile. Corresponding to this, let the projection on the frontal is like this. Again, I had a choice. I could have made the projection this way also, or this way also, or this way also, any of these. But the moment my projection is fixed in the profile and the frontal, the projection on the horizontal will be fixed. So let us draw now the projection on the horizontal with the help of the middle line and the projectors. This is how the line will appear, and we know in this case all three views are foreshortened. One question before we go to the next slide is, if a line is inclined like this, how can we determine, or oblique, how can we determine its true length? Because its true length is not coming in any of the views. All these three views are foreshortened. And this kind of problem we'll face very often, as also we saw here. Okay, so what we will do, look at this line. If somehow I can find a plane which is parallel to this line, this plane is not along the frontal or profile or horizontal, but somewhere else. And if I can project this line onto that, I will have the true view of this line. So we will see how to identify, locate this plane, and this plane we will call auxiliary plane, and the view will be auxiliary view. I'll show you this by an animation, and we'll follow step by step. Let the line is here. Again, visualize the frontal plane, the profile plane, and the horizontal plane. Always visualize those. Our idea is to find this plane which is parallel to this line. Okay. Now, for a given line AB, let this is the frontal plane, let this is the profile plane, and let this is the horizontal plane. Alright, and so the frontal plane, horizontal plane, profile plane, and the line is somewhere here. That is how the case is. And in any of these planes, the view of this line, the projection of this line is foreshortened. We are trying to identify another plane which is parallel to this. How we locate that? That is the idea. So if the projection of this line we draw on frontal and on horizontal, that is how the projections will appear. But they are foreshortened. What we will do now, we'll use a concept. It's a very important concept. If you visualize it, for this line, which plane will be parallel to this? So if for this line, its projection on the horizontal, let's say this is the projection of this, the line here on the horizontal. Okay. If I look a line here, so that's the line, or rather I will say that's an edge view of a plane. Okay, because the plane is going perpendicularly downward from the horizontal plane. So there is another plane which is going like this, but the edge view of this plane and the projection of this line, they are parallel. Okay, so the meaning of this is the line down there is parallel to the plane. That's why the projection of this on the horizontal is parallel to the edge view of the plane. So we will make use of this concept in order to locate where is the auxiliary plane. Let us do it. So using this, parallel to this is the edge view. So let this line is the edge view if you see it from the top. Okay, that's the edge view. And these two are parallel. So the plane which is going down is the auxiliary plane. Let on this auxiliary plane we project the line. So I'm using the projectors and projecting it onto the auxiliary. So this is the viewing direction perpendicular to the auxiliary plane, and this is how the projection of the line will appear. So this is the projection of the line onto the auxiliary plane. Now one more thing here. Can we say something about how much below this line is from the hinge line or from the horizontal plane? Again, we will make use of one more concept here. Just think of the concept. The concept is this. If this is the line, that's the horizontal plane, frontal plane, and this is, say, the auxiliary plane. So auxiliary plane is parallel to this. I know the projection of this line on the frontal plane. Okay. So from the horizontal plane, there is a hinge line, down goes the frontal plane. So from the horizontal plane, how much below are the ends of this line? It is known to me by the projection of this line onto the frontal plane. So I can say I'm talking about this distance and this distance. This distance is known to me because the projection of the line is known to me. Well, the interesting thing is, because my auxiliary plane is also orthogonal to the horizontal plane. So it is same as the frontal plane. So as far as the line is concerned, the line's projection onto the auxiliary plane will also be at the same depth from the horizontal plane, at the same distances from the horizontal plane. So the two ends of the line A and B, whatever, whichever distance they are below the horizontal plane, and I know it from the frontal projection, same distances are also applicable for the auxiliary plane. Well, we'll make use of this now. So I will also later on talk about these three planes. I'm giving them name is A1, A2 and A3. First, let us see the distances. So this distance and this distance are same. So that is how on the auxiliary plane I can locate the point. Also, the distance here and the distance here both are same, and this is how I can locate the point on the auxiliary plane. So what we did, I will just repeat it. From plane which is horizontal, we will call it as A2. I am drawing the projectors to the auxiliary plane. Number one, on those projectors I am locating the ends of these lines, of this line, using the distances from frontal, that means from A1. So whenever we have an auxiliary plane, which we will call as A3, so to locate or to project the line on A3, what are the steps? The first step is we will identify the direction of the auxiliary plane using the projection of this line onto the horizontal, or A2. Okay, and then from A2 we will draw the projectors onto the A3, and we'll take the distances from A1 and apply those on A3 in order to get the projection which is here, the normal view.